Hello, this is Britt Caswell with another example video. In today's video, I'm covering example 2 from 6-3 in the SavvasRealize Algebra 1 textbook. The goal of today's video is to understand exponential models of growth. Alright, so the first thing that I need us to understand is some of this vocabulary, because this is a very vocabulary dense kind of section. Okay? So the first thing is I want us to understand a certain amount of time. All right. A lot of these problems, they talk about like a length of time, such as bi-weekly or semi-monthly, and they never actually tell you what it means. So understand that the prefix bi means every 2 of whatever that unit is. So bi-weekly is every 2 weeks. Bi-monthly is every 2 months. Biannually, every 2 years. The word semi, or the prefix semi, tells you it happens twice per that unit of time. So semi-monthly or semi-annually. So that would mean like twice per month or twice per year. Annually, of course, means yearly. And quarterly means that it happens every 3 months or 4 times a year. Okay, so be aware of that. So just make sure that you're aware of what bi and semi mean, and you could probably get away with the rest of it. Okay, so now we have this idea of compounding. Okay, to compound just means to calculate interest. I'm going to write that across the top here. So I want to explain to you what we mean by compounding. So I'm just doing like a quick little side discussion here at the bottom before I get into the rest of these problems, okay? So say, for example, I put $1,000 on my credit card. All right? And I'm going to say that my interest rate on that credit card is 10% each month, which is a ridiculous rate. Don't do something like that. But there we are. So if I get this credit card, $1,000 that I put on it, I'm going to pretend I'm not very responsible and I don't pay it. So once that month is over and we start our second month, not only do I have the balance of the $1,000 on there, but I also have that 10% interest. So I have an extra 100 on there. So now my balance on my credit card is $1,100. Now I'm going to keep being irresponsible. I'm not going to make any credit card payment. So here comes my next month. So my next month, they go to calculate the interest again. But instead of calculating it based off the original 1,000, they do it based off your account balance. So my account balance now has the $1,000 and the $100 worth of interest. So my interest that's being added on this month is now $110, which changes my account balance to be $1,210. Just to further make the point, I'm gonna not pay my bill again. Understand at this point in time you probably have some kind of late fee on there, which is making this even worse. So I haven't paid anything, so now my money being added that I'm going to owe is $121. And so now my account balance is now $1,320. So not only is my account growing, the amount that's in my account, but look at how much interest I'm paying each time. So this is me paying interest on interest. And so that's what the idea of compounding is to pay interest on interest. And so it starts to grow, and you can see this is starting to grow at a rate that's following exponential growth. All right, so this is the idea of any type of loan that you do, not just credit cards, but like your car, your mortgage, student loans, okay? And it's how banks make their money. So again, the idea of compounding is when you're paying interest on interest. It's when the interest is calculated. Alrighty, so now let's get into the word problem. Actually, no, let's get into the formula. Spoiler alert. So with this idea of compounding, we have to kind of modify our quadratic growth equation. So remember how we had split up our b value into 1 plus r. So that was for continuously compounding. So if there's not like a set schedule for compounding, that means that it's growing at a continuous rate. But here, now what we're doing is we're bringing in this concept of compounding, okay? So what we do is we take that rate is now our annual rate, so how much it grows in a single year. And then this m that appears twice happens to be the number of times a year that something's happening. Is it quarterly? Because if it's quarterly, it's happening 4 times a year. If it's semi-annually, it's happening twice a year. Okay, so there is kind of a new formula. And to help prevent you from getting confused, this formula is named the compounding formula, or the compounding interest formula. And that's going to be kind of our go-to. Alright, so here we go. So Kimberly's father invested in a certificate of deposit, also called a CD, for her when she was born. The interest is compounded quarterly. So y'all are high schoolers, you probably don't know what a CD is. A certificate of deposit is a type of investment where a person is borrowing or giving money to a bank. Alright, so you're depositing a certain amount of money in the bank and you're promising them that you can't touch it. And so what they do is the bank will go and they will invest that money in places that compound more often, and they will get more money off of it. And so in the end, after your time's up, you get some of the interest and the bank gets the rest of the interest because they invested it elsewhere. So that's what a CD is. And so they want to know what the value of this CD is at the end of 5 years. So what we need to do is we need to identify some of our variables. Okay? So my stuff that I need to identify, I need the P, which stands for the principal amount, or the initial amount that gets deposited. So according to this note, it says that you deposited, or Kimberly's father deposited $3,000. We need the R, which is the annual interest rate. So this certificate says that it's 8%. Remember, you can't put a percent into an equation. You have to change it to a decimal. So that's why it's turning into 0.08. My M is my number of times that it's compounded per year. So this is telling me that it's compounded quarterly, which means that my M value is 4. And then my T is the number of years that we're going to follow this through with. So this says that I'm going to be doing it for 5 years. So now I have enough information gathered that I can use this formula to figure out the amount of the CD at the end. So A is the amount at the end, is equal to our principal amount, so that $3,000, times 1 plus my rate divided by my M, my compounding number. So I'm going to do 0.08 divided by 4. And then our exponent is our compounding number times the amount of years it happens. So 4 times 5. Alrighty, so now we just got to clean it up. So the first thing I would do, even before you plug into some kind of calculator, is I would actually simplify some of these numbers. Because the more operations you have to type into a calculator, the more likely you are to get some kind of error because of user error, okay? So here in the parentheses, okay, 0.08 divided by 4 is 0.02. And if I add 1 to that, I get 1.02. which is a lot easier to type into the calculator. And for my exponent, 4 times 5 is 20. Now that is something that's doable. Now if you have one of those kind of like cheap calculators, the scientific calculators, I would just do the 1.02 and raise it to the 20th power, and then multiply it times the 3000. Now since I want you to be able to see what I'm doing on my screen, I'm just going to use Desmos to do this calculation, but I'm going to split it up how I would do it in a normal calculator. Okay, so 1.02 raised to the 20th power. Alright, now that's this hideous decimal. Now I could take that decimal, I don't know how to do it on a second line on Desmos, but I could take that decimal, I'm gonna put this expression in parentheses, telling my calculator to do that calculation first, and then I'm gonna do the 3000. Now your problem has a 3000 out here. That's fine. It doesn't matter. It could be either the front or the back. So anyway, so your CD is now $4,457.84. Remember to make sure that you're rounding to the nearest penny, right? Because this is money. So again, our CD, our A value, was $4,457, and I have terrible memory, and 84 cents. Now normally I'd recommend answering this as a word answer, but I'd rather just move on in the video. So now they want us to do a comparison, okay? So we're going to have the same CD, okay? It still has the principal amount of 3,000. It still has the rate of 8%. Oh, that's not going to clean up with Control Z, okay. So it still has that rate of 0.8%. But what we're doing is we're going to compare our compounding rates. So they want us to look at what if it's compounded annually, so once a year, versus quarterly, which is 4 times a year. And they want us to do it for 15 years. And so in this problem, they want us to compare the amount of the CD afterwards so that we could see what that compounding does. Okay? So we're doing this calculation twice. So where the P is, I still have my 3,000. Here I'm going to have R divided by M, so 0.08 divided by 1, and then 1 times 15. And then here, the only difference is that that 1 becomes a 4. So now let's check it out. So simplifying a little bit before I calculate. Inside the parentheses, 0.08 divided by 1 is just 0.08. And if I add 1 to that, that's 1.08. And then here, 1 times 15 is 15. On our second one, 0.08 divided by 4 is 0.02. Add 1 to that, you get 1.02. And 4 times 15 is 60. So you can see here where the rates are different, right? Here where it's compounded annually, I'm doing all of the interest at once. Here where it's quarterly, I'm only doing a quarter of the interest at once. But the amount of numbers of times that it's compounded is now different. And so we're going to use Desmos to do those two calculations. Okay, so since I already have 1.02 here, I'm just going to change that 20 to a 60. So 9843.09, 9843.09, 9843.09. So about $9,800 for this situation where it's raised to the 60th power. So now our interest is going to change, right? Now our interest is taken at the '08 amount, and it's only happening 15 times. So look at that change in money. Now it's $9,516.51. Just checking to make sure I wrote that right. Okay. So just by compounding it more often, okay, these have the same number of years, but by compounding it more often, do you see how the quarterly produced over $300 more than the other one? All right, so that idea of compounding is how people make money, is if they compound it more often in their calculations than when they lend it out to somebody, or when they borrow it from somebody. All right, so here we go. So this one, the try it, it says what would be the difference after 15 years if the CD is compounded semi-annually rather than quarterly? Okay, so we just did the quarterly calculation. So I'm just going to use my snipping tool to copy that quarterly calculation so we can compare it instead of doing it a second time. And that was a bad snip because I left out the 4 to the 15ths. So I'm just going to put that right there. I'm also going to go over this in white so it's less obnoxious looking. So there we have it. So there is our quarterly compounding. So now let's look at semi-annually. Now notice this is asking for the difference. So this is actually asking us to calculate them both and then to subtract them. Okay. So again, the only thing changing in this formula is that m value. Okay. If it's happening semi-annually, that means that it's happening twice per year. So if I clean up my parentheses a little bit, 0.08 divided by 2 is 0.04. So this turns into 1.04. And 2 times 15 is 30. So now let's go into Desmos. We're going to change this to a 4 and this to a 30. We get 9,730 and 19 cents. All right, so those are our two amounts. And so the difference, right, because that's what it's asking for. So I'm going to take the 9843.09 and I'm going to subtract the 9730.19. Okay. Now I don't want to have to transfer between windows over and over because I'm bad at remembering numbers like that. So I'm just using my phone calculator real quick just to do that subtraction. And I got 112.90. Alright, so when you compound 2 times a year instead of 4 times a year, that difference was only $112. And so now they want us to take that quarterly calculation, which we already did up there, and check it out monthly. Okay, so now our formula, instead of there being a 4 where the m is, now we're doing it with a 12. Now, monthly is the smallest amount of time that we've broken it up into, right? So we're compounding it way more than we have in all these other ones. So because that compounding is so intensive, you betcha that we're going to have, more money out of this. Okay, so 0.08 divided by 12 is 0.00666667. Because because that number continues on for forever like that, I don't want to round here before I do this problem. Okay, so I'm actually going to input it into Desmos, into my calculator, as it is there. Okay, so then here, 12 times 15 is 180. Okay, so that is what I'm plugging into Desmos, so let's go ahead and let's give it a shot. So I'm going to scoot the exponent out to here. So see how much more work it was to type it in now? And so the amount I get is $99,920.76. Okay, and we can compare that to the quarterly calculation, right, of 984309. And so the difference, we would take that 992076 and I would subtract that 984309. And again, I'm just doing this on my phone calculator because jumping over is really annoying. That would be 77.67. Alright, so the 12 months versus the 4 months was only a $77 difference there. But check it out, like when it was just once, right? When I compounded once, that's quite a bit. That's $400 more, okay? So there we have it. That is how to calculate using exponential models of growth using money with compounding. Until next time.